All right, guys, I'm going to go through some two-step equations, and these have decimals and integers in them. So with two-step equations, we always kind of think about unwrapping a present. So think about a present that's got the wrapping paper and it's got the ribbon on it. So when you undo a present, it's a lot like undoing your two-step equations. So in order to open the present, you have to first take the ribbon off, and then you can take the paper off, right? You can't get all the paper off easily if the ribbon is going all around it. So you have to take the ribbon off first, and then take the paper off. Same thing here. There's a certain order we have to undo. So like a certain piece of the problem we have to do the inverse operation of first before we can do the second step. And I always think of it also as inverse order of operations. So I'm going backwards order of operations. So here, 5x plus 12 equals 27. The first thing I need to get rid of is this plus 12, because that would be the last step of order of operations. So I'm going reverse, so I'm going to get rid of that first. So first thing is to subtract 12. So almost always you're going to get rid of the constant first. There's a couple situations where that won't work, and I'll show you those too. So if I subtract 12 over here, that's gone. I still have 5x left over. On the other side, 27 minus 12 is 15. So 5x equals 15, but I'm not done yet. So now I can get rid of that coefficient. So it's multiplying by 5 right now. I'm going to divide by 5. So x over here equals, and then 15 divided by 5 is 3. So x equals 3. Okay, let's look at this one. So let's see. I need to first get rid of that constant. So I'm going to add 6 to both sides. Over here, that cancels those two out, and I have b over 4 equals, and then 9 plus 6 is 15. Now I need to get rid of that 4 that's with my b. So it's dividing right now. I'm going to multiply by 4 to do the inverse. So over here I get b equals, and then 15 times 4. So 5 times 4 is 20, carry my 2. 4 times 1 is 4 plus 2 is 6. So b equals 60. And don't forget that you can still plug these in to check them. So I'll just do that off to the side just to remind you. So if I put 60 over 4 minus 6, I would need to simplify the 64ths first. So 60 divided by 4, 4 goes into 6 one time. 2 left over, bring down my 0, 4 goes into 20 5 times. So this is 15 minus 6, and then 15 minus 6 is 9, which is what my original answer was supposed to be. So I know that I got it right. All right, let's look at this one. So first I'm getting rid of my constant. This is a little tricky though. So how I like to think of this is, remember that when you have subtraction, it's like keep, change, change. So I'm going to keep it, change this to addition, change this to a negative. So now you can kind of see that these two numbers are being added together. It's just a positive plus a negative instead of thinking subtraction, because I'm afraid some of us are going to do the wrong operation if we leave that as a subtraction sign. So now I can see I'm adding a positive 34, so I'm going to be subtracting a positive 34 instead. Okay, and then over here, right, this is like keep, change, change. I'm like adding a positive and a negative, so different sign, subtract. 34 minus 18, and I need to borrow. 14 minus 8 gives me 6. 2 minus 1 is 1, so 16. So I have negative 2y equals negative 16, because keep the sign of the larger number. The 34 was larger, and it was negative. Now I can divide by that negative 2. Divide by negative 2. Over here I get y equals, and then negative 16 divided by negative 2. Well, 16 divided by 2 is 8. Negative divided by negative makes it positive, so y equals positive 8. Again, you can always substitute it back in to check yourself. That might help you check your sign. Also, if maybe you accidentally did the wrong operation with that 34 at the beginning, that should help you realize that you did something wrong. Okay, let's look at this one. So think about what you think the first step should be. Hopefully you are thinking we should subtract 7 because that is what we should do. So that's canceled over there. We get negative 4m equals, and then over here 12 minus 7 is 5. Then this is being multiplied, so I'm going to divide by negative 4, divide by negative 4. I get m equals, and then I have 5 divided by 4. Two different ways I could do this. I could actually divide that, which I'll show you real quick. 5 divided by 4 goes in one time, 1 left over. I can leave it like that and, well, never mind. I'll show you that in a second. I can go ahead and add my 0 and bring it down. So 4 goes into 10 2 times, which is 8. Add another 0, bring it down, goes in 5 times. So I could have this as a 1.25. It was a positive and negative, so a negative 1.25. Or I could have this just as a fraction, 5 divided by 4, and then just simplify it to 1 1/4. I think that's easier, so that's probably what I would have done, and had just negative 1 1/4. But either way is totally fine. We will accept either one. Especially since the original numbers were just whole numbers. If they were originally fractions, I would expect your answer to be a fraction. If they were originally decimals, I would expect your answer to probably be decimals. But here, either way would be just fine. Okay, here's another little bit tricky one. Remember that when we get rid of a minus negative, we're only ever changing the operation, not the sign. So instead of subtracting negative 5.5, I'm going to be adding negative 5.5. Adding negative 5.5. Same signs, add and keep. So I'm going to do 24.5 plus 5.5. Don't forget to line up your decimals and add. Put that decimal in there. So I'm getting that 0.5f equals 30. It was a negative plus a negative, so negative 30. Now I can divide by 0.5, divide by 0.5. So f equals, and then I actually need to do that division, so 30 inside, 0.5 outside. Remember to slide, baby slide. There's my decimal, slide it over. So it's really 5 going into 300. 5 doesn't go into 3, goes into 36 times, exactly. But I still have to use the 0, so 0. So f equals 60. It was a negative divided by a positive, which would be a negative. So f equals negative 60. Remember, that's your sleeping dog. All right, let's check this guy out. So, draw my line. Go ahead and think about what operation we should do first. What step are we going to undo first? So the first thing we should be doing here is adding 9.7, adding 9.7. It's a negative plus a positive, so different sign, subtract. So 9.7 minus 7.0. Remember, line up those decimals, and then you can subtract. So I get c over negative 2 equals positive 2.7. This is dividing by negative 2, so we would multiply by negative 2. Go ahead and do that multiplication. Okay, let's see. I'm getting 5.4. It's a positive and a negative, so c equals negative 5.4. Okay, I really want to talk about this one because it is different. So when you have more than just one thing on top of the fraction like this, like I have v minus 4.9 as my numerator, this is really saying that that whole thing on top is all being divided by 0.5. So it's kind of like v minus 4.9 in parentheses, all of that divided by 0.5. So if we think order of operations, I would have to, let's say I knew what v was, I would have to solve this first. That would be step 1, and then this would be step 2. Well, since we're doing reversed order of operations, that means I need to actually take care of step 2 first and then step 1. Okay, so I'm going to have to use, get rid of that 0.5 before I do anything else. Okay, so since it's dividing by 0.5, I'm going to actually multiply by 0.5, multiply it by 0.5. So on this side, I get v minus 4.9 equals, and I'm actually going to do that multiplication over here, so 1.38 times 0.5, 5 times 8 is 40, 15 plus 4 is 19, and 5 plus 1 is 6, and then don't forget to put your decimal back in, 1, 2, 3 spots. So v minus 4.9 equals 0.69. And then it's subtraction, so I'm going to add 4.9. Add 4.9. So v equals, and then, oh, I forgot one thing, sorry. Back here for the 6.9 or the 0.69, it was a negative times positive, so this should be a negative 0.69. So when I add a positive and a negative, I'm going to actually subtract. So I'm going to do 4.9 minus 0.69. Put that placeholder 0 and borrow. So 10 minus 9 is 1, 8 minus 6 is 2, decimal, and 4 minus 0 is 4. So v equals 4.21. I would keep the sign of the larger number, which was my positive, so positive 4.21. Okay, I'm just going to do a couple more with you. So look at it. What would we get rid of first? We are going to get rid of that 0.7 first. So why don't you go ahead and try to do this problem, pause the video, and then come back and I'll do it with you. Okay, so first this is adding a positive 0.7, so I'm going to subtract positive 0.7, subtract 0.7 on both sides. So I have 34.2 minus 0.7, and I'm going to borrow. 12 minus 7 is 5, bring down my decimal, 3 minus 0, 3 minus 0, so I get 5x equals 33.5. Okay, then I need to divide by 5, so x equals 33.5 divided by 5. Don't forget to raise your roof. Whoop, whoop. 5 goes into 3 0 times, but goes into 30 6 times, which is 30. 3 left over, bring down your 5. And 5 goes into 35 7 times, which is 35. So I'm getting 6.7. It was a positive divided by a positive, so positive 6.7 equals x.